Good morning. I'm Bo Strickland. I'm an instructor at Red Hat, and this morning I would like to give you a taste of training from our RHCSA Rapid Track course. This course is used to prepare experienced Linux administrators in the Red Hat way of doing things and prepare them for the RHCSA certification exam. What I would like to talk about this morning is making use of logical volume management snapshots. Snapshots are a wonderful ability of logical volume management to be able to very quickly freeze in time a logical volume, and so that you can come back later and refer to it. One of the advantages of logical volume snapshots is they use only a fraction of the logical volume that you're duplicating. And so essentially, as long as the logical volume, the data in the logical volume is not being changed, the snapshot and the logical volume look at the very same data. As data gets changed within the logical volume, however, the original data uses a copy on write technique so that the snapshot preserves a copy of the original content of the data. And in order to do this, I'm going to make use of a Red Hat Enterprise Linux system. I'm going to be using logical volume management, so I'm going to go ahead and become root on the system. And using VGS to scan my logical volumes, I find that I have a logical volume with about 12 gigs available. Using LVS to look at the logical volumes that are found within that volume group, I have logical volumes that look like they're backing up my home, my root file system, and maybe a virtualized guest. In order to illustrate the idea of a snapshot, I'm going to create a logical volume using LV-create. I'm going to call this logical volume LV data, and I'm going to make it about 100 megs in size out of the volume group vol 0. Taking a look at that, I now have my logical volume. It got rounded up to about 128 megs in size. Let me lay down a file system, makefs.extended4, on dev vol 0 LV data. Let me now make a mount point that I'm just going to call mount data and mount my logical volume to it, vol LV data to mount data, so that if I look, I have about 113 megs of usable space mounted to mount data. Having done this, let me go ahead and copy some data to it, and I'm just going to take some arbitrary data. The etc sysconfig directory has a lot of text files, and so it's easy to manage, and I'm going to copy that over into my mounted logical volume. If I take a tree of that information, let me go ahead and cd into mount data and take a tree of sysconfig, then we find that sure enough there is a collection of files now that are within my logical volume. Coming back out, if I look at my logical volumes again, at this point I want to take a snapshot of this logical volume, so that this data partition, so that I can freeze it in time and maybe come back and do a consistent backup of it at my leisure, or have a history of it that I can come back to at a later time. In order to do this, I'm going to use the same LV-create command. If I ask for help from LV-create, however, I find that LV-create in general is used, as I have used it, to specify a new name and a new size for a logical volume. There's a second invocation, however, where you can ask LV-create to create a snapshot, and what you reference is the original logical volume that you're snapshotting. You also get to specify the size, and this is where it takes a little bit of guesswork, because what you need to think about is how quickly is your data changing and how long do you want to keep your snapshot available, remembering that it's only changed data that needs backing store within the snapshot that you're creating. And so for me, I'm going to say LV-create. I would like to make a snapshot. The logical volume that I am snapshotting is the LV data volume. The size that I would like to make it is I'm going to be very conservative and try to just make it 12 megs in size. Now it ends up that got rounded because of the size of my physical extents to 32 megs, but now then if I use LVS to look at my various logical volumes, I find that I have my original data, which is 128 megs in size. I now have a new logical volume that I didn't name, which is a snapshot of LV data. All right, now that I have created a logical volume and have data within it, if I take an LVS scan, here's the logical volume storing up the data. What I would now like to do is take a snapshot of it using LVM snapshots. In order to create my snapshot, I'm going to look at the LV create command page, or really just ask the LV create command for help. And what we find is that there's two different ways LV create can be invoked. One is just to create normal logical volumes, as I have done. The other, however, is that if you invoke it with a -s or a -- snapshot, you are specifying that the new logical volume you're creating should be a snapshot of an already existing volume. You have a path, you then specify the path to the volume that you would like to snapshot. You then specify the size that you would like your new snapshot to be, and this is what involves a little bit of guesswork. Remembering that it's only change data that requires backing store within your snapshot, then you need to think about how quickly your data is changing and how long you would like to preserve your snapshot. And that gives you the guesswork associated with the size that you would like the snapshot to be. Before I take my snapshot, in order to have consistent data, I'm going to unmount my file system. I'm now going to say I would like to LV create a snapshot. The logical volume that I am creating is dev vol0 LV snap, or the logical volume, LV data that I'm snapshotting. The name I'm going to give this is LV data snap, a snapshot of LV data. The size, I'm going to be very, try just for 12 megs in size for the snapshot. It looks like the size of my physical extents are 32 megs in size, so it got rounded up. But if I now take an LVS and to scan my logical volumes, I have my original 128 meg data logical volume. I also have a 32 meg snapshot, which is a snapshot of LV data with very little of its storage actually allocated yet. Let me now mount dev LV data back to, or my logical volume back to the mount point of mount data. And to illustrate the idea, the snapshot, I'm going to make a new mount point that I'm going to call data snap. And to it, I'm going to mount the LV data snapshot to mount data snap. In practice, snapshots are actually read-write, which allows you to have some interesting use cases. For my use case, where I'm just trying to have a preserved copy of my logical volume, I'm going to mount it read-only so that I don't modify that preserved copy. Now then, if I were to take a tree of mount data sysconfig, and to get the point across, I'm really just going to list the directories that are contained within that directory. This is my original data. I'm also, in a different window, going to take a tree of mount data snapshot sysconfig, and again just listing directories, and see that they are consistent copies of the same. If, however, I were to go